Guys, this is just going to be a quick review of graphing linear functions. So key thing you should remember when you're graphing linear functions is that we always wanted it to look like this. We wanted it to be in that y equals mx plus b form. And hopefully you guys remember that when we were dealing with this, that the m was the slope. And the slope always told us like the rise over the run. I don't know what this new situation is. It looks like blurry when I first write it, but I don't know. It's weird. And then for B is the, I'll have to write it over here just because of space. B is the, I have space at the top here. Okay. B is the y-intercept. So let me move it over there. Is the y-intercept, and y-intercept means it's where the line touches the y-axis. All right, so you can write touch y-axis. All right, so these are the two key things that we need when you're trying to graph a line. The x and the y are going to remain variables because, you know, whatever you plug in for x will determine, you know, what y is. That's what it means by a function, that one of the variables depends on the other. So when it comes to graphing these lines, what you want to do is, again, make sure it's in this form. This is called slope-intercept form. And as long as it's in your slope-intercept form, this is going to be, I've got to get used to writing on my screen again. So excuse my handwriting for the first couple of days. So when it comes to this, this is going to be the rule. So basically, these are the steps we're going to follow. First, you're going to start at B, and then you move with M. So let's look at the first example and I'll explain this. So if we look at this equation, I'm just going to write down what M and B are for number one, just so we're clear on what those two values are. So for this one, M is 3/4 because it's always the coefficient of x, and B is -9. You got to take that sign with it. It's a -9. So again, B is where we start. So what I told you from the beginning is that B is the y-intercept. So it's where it touches the y-axis. So I know that this line is going to touch the y-axis. This is y, this is x, at -9. So that's going to be my starting point. I always start at B. Then the slope tells us how to move. It tells us like a map, like every point is this far away from the previous point. So with our slope being 3/4, again, it's rise over run. So from this point, so don't go back to the origin, that's a mistake a lot of students will make. From this point that you just plotted, B, you're going to go up 3. Let me use a different color here. You're going to go up 3, and then you're going to go to the right because it's positive. Sometimes it'll be negative, things will change a little bit. So it's going to be rise 3, 1, 2, 3, run 4. And then you keep going. You can do it again. 1, 2, 3. 1, 2, 3, 4. And you could keep going, but this won't fit on the graph. So ideally, again, you would keep going on forever. But for what we have, this is sufficient. You always want to put arrows at the end of the line because it's infinite. It would keep going on forever. That's how you graph a line. So let's look at the second example here. For the second example, again, this is our slope-intercept form. So for this one, M is -3 and B is 5. So again, if we're following the directive here, 1, B tells us where we start. So we're going to start at 5. And again, it's always on the y-axis. So the y-axis is the vertical axis. So we're going to start this time at a +5 because it's a +5 here. So that means +5. And then the slope is a -3. Now, again, I'm trying to do like one of each kind of type here. When the slope is a whole number, you want to make it into a fraction. And remember, you can make any number a fraction by just putting it over 1. So we can easily make this a fraction. So now we have our rise over run that we need. Now, the other thing we have to take into consideration here is that the slope is negative. Because it's a -3, we don't want to go 1, 2, 3, 1. That's not going to work. Whenever it's a negative, you have a choice. You can either do -3/1, or you can do 3/-1. The mistake is to do this. You can't do both negative because remember, if you had a negative divided by a negative, that's going to be a positive. And again, therefore, that wouldn't be the negative slope we need. So from here, we're going to go up 3 and left 1 because that would be the rise 3, but left 1. We can also go down 3, which is this option. If we go down 3, then we go to the right one. To the right one. Down 3, right 1. And we keep going to the end of the graph. I tend to always just go down first, just because I won't forget to do the negative. Sometimes, again, students forget the negative and we'll have a line going like this, which obviously has a positive slope. All right, for the next example 3, this is like the hardest one that you'll see when it comes to graphing them. And the reason this one's a little bit harder is because it's not in the right form. If you're looking at this, it doesn't look like our slope-intercept form. To be slope-intercept form, we need the y by itself, and then our mx plus b on the other side. So this is when your ability to solve for a variable comes in. That was another Algebra 1 concept. So you want the y over here by itself. So for the y to be over here by itself, what needs to move? We need to move the 6x. So we're going to do a minus 6x. From both sides of the equation, as always. That's the only way we can move something. At this point, we have a negative 7x equals, I'm just going to put the 6x first, so it's still in the mx plus b form. Now, why didn't I combine those? Hopefully nobody thought to subtract those and put 22x or etc. Because one's an x and one has an x and one does not, so they're not like terms. So we can't actually combine these, so we can only just put plus there. We can't actually add them. So next thing we're going to do is get rid of the 7, because if we look at our slope-intercept form, it's always 1y, not, oh, I'm sorry, I put an x there. Let me fix that. It's always 1y, not 7y. Get a little negative 7y. So we have to fix this, and don't forget to bring the sign down with that negative 7 as well. So we're going to end up dividing by a negative 7. Why do we do that? We do that because we want y to be 1, or 1y. So 7 divided by 7, or negative 7 divided by negative 7 is 1. So that's why we do it. So we now have, I'm going to write it down here, y equals, a negative divided by a negative is a positive. So we're going to put 6/7 x. We never want to put we never want to put the slope as a decimal. We always want it to be a fraction, so we know to go up 3 over 5, down 2 over, we always want a ratio, never a decimal. And then the last thing, we have 28 divided by a negative 7. That's going to be a negative 4. So graph, start at B, it's negative 4. And then we do rise over run. So rise over run for this one is going to be up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And we could go again, possibly. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6, 7. So that's going to be our line. All right. Okay, here are the next two. I'm going to pause my video. I'm sorry, I would pause my video if I was you guys for a minute and try them. I'm not going to go through these. I'm just going to show the answers. So pause it, give it a try before you continue the video. Okay, so hopefully you guys gave these two a try. Here are my answers for B and C, the next two examples. And I'm going to move down here. This one is multiple choice. Basically asking you to solve for y. So again, that process would be getting this by itself. So I do minus 3x. I get 2y equals negative 3x plus 4. Divide everything by itself. I end up with y equals. Again, you always want the slope to be a fraction. And that's my answer. So I find the one that matches up. I know it's one or it's the other because I have a negative slope. And the answer is going to be A. right, and then on the next page, it's graphing the linear inequalities. So graphing the linear inequalities is pretty much parallel to graphing the linear equations. The main difference, much like the regular inequalities that we just went over, is that you have to shade. It's like some shading involved in the end. So let me just go through it and I'll clarify, how it changes up. So key things you want to keep in mind is the type of line. So just like with the inequalities, we had our open and closed circles. When we're graphing the lines, we have solid and we have dashed lines. The line is going to be solid whenever you see the less than equal to, greater than equal to, and obviously just equal to. And then it's going to be dashed whenever it's not underlined or we have not equal to. And basically that's just letting you know that the line itself doesn't count. It's not part of the solution set. So how does this look? Let's look at example like number 1. So again, we approach this the same exact way we do the lines. We look at this as basically like it's y is less than mx plus b. We think of it the same way with in terms of the slope and the y-intercept. So for this first example here, my m is -2 and my b is 5. So again, we start at b. So we're going to go to +5. And then we move with m. So m is -2. Remember, we can't have one number. We always need that ratio so we can put it over 1. So we're going to go down to over 1. Go to the end of the graph to check on down to over 1. And we can also show it to go up. If we went up, then we would have went in the negative direction to the left. This is our line. Oh, I forgot to even think about it, but it is going to be solid. So again, because it's an inequality, you now need to stop and think, is this line going to be solid or dashed? Because that's important before you draw your line through it. So this line here, I'm looking at the symbol. This is the symbol. It's underlined, so this is going to be a solid line. So I'm just going to go make a solid line through the points here, and etc. So now basically at this point, I have two parts of my graph. I have A, which is over here to the left, and then I have B, which is over here to the right. And I need to decide which one to shade because this is, again, an inequality. So it's like our number lines before when we have our shading, etc. So whenever it's an inequality, we're going to have some type of shading involved. So now we have to figure out which side of the graph to shade. Now, the side of the graph that we're going to shade is going to come from us, again, reading the inequality. So let's look at it. This says y is greater than the line, basically. So this is our y-axis. Common mistake is a lot of students think in terms of x, so they're thinking a number line going horizontally, this being the big side over here and this being the small side. But this is not talking about x, we're shading for y. So when we're looking at the number line, basically, we're looking in terms of this vertical line because we're shading for y. So up here, this is where it gets bigger. This is 6, 7, 8, 9, 10. And this is where it gets smaller along the y-axis. So this says y is greater than the line. So that means we're going to shade this side of the graph, B. And that's because over here, if we look at the number line, this is where your y values are getting bigger. It goes from 5 to 6 to 7 to 8, yada, yada. It's increasing. So we're going to shade the B side of the graph. Let's move on to number 2, or for letter B here. So for letter B, again, m is 1/4 and b is -3. We always start at b, so I'm putting my first point at -3. Our slope is 1/4, so we go up 1, rise, 1, 2, 3, 4, overrun, up 1, 4, down 1, 4. 4. Now this line is going to be dashed because it's just greater than, no underline. So dashed here. So I'm going to come over here and make a dashed line through these points. So basically show up like that. So here are my sides of the graph, A and B. So again, we are shading in respect to the y-axis. So this is our y-axis. It's the vertical one. This says y is greater than the line. So this is -3. Where do the y values get bigger? Since it's greater, A. We should be shading A. Which inequality is graphed at the right? So first of all, it's dashed. So because it's dashed, you should be looking for it to be one of these two symbols, one of these three symbols. So all of those have the right symbol, so no issues with that yet. Sorry. All right, next thing I know is that because it's shading up here, y is more than the line. It's greater. So I know it's going to be either that's less than, so no, and that's less than. So now I'm stuck between G and J. Now deciding between G and J, first thing I can look at is B, check and see if the y-intercept is the same. And they both have a y-intercept of 1. So can't do anything with that. So the next thing I need to look at is the slope. So if I'm looking at the slope, this is up 1 over 2. The slope is 1/2. The next one, number 3, says which quadrant will be completely shaded by this graph. So in order to do this, I'll just do a little sketch over here. First thing, know your quadrants. This is 1, this is 2, this is 3, and this is 4. They look the same, so let me fix that. This is 3 and this is 4. All right, so keep that in mind. Now it says which quadrant will be completely shaded by this graph. So I'm just going to do a quick sketch. It doesn't have to be a perfect graph. There is no B. I don't think we've done any like that. So if there's nothing there for B, that means you're starting off at 0. It means there's no B. B is 0. It's not that there's no B. There's nothing to write. Like you don't put plus 0. I have $7 plus $0. Like it's unnecessary to put the plus 0. Anyway, and our slope is 3. And again, it's a whole number, so we put it over 1. So that means from here, we're going to go up 3 and 1 to the right. And we will keep up with that pattern. Down 3. This line would be dashed because of the symbol. And it says y is less than the line. So this is your y-axis, the vertical one. Where does y get smaller? On this side. Which means the quadrant that's fully closed off or fully shaded is this one down here, which is Q4. Oops, I must have, when I posted the picture, I must have overlapped here and cut off Q4, sorry. But it's Q4, and that's the end. Gotta overlap my picture there, but that's all right. Next one, and final one here. This one you need to graph it. So again, this is kind of like our other ones, we have to solve for y first. So I'm going to pause the video for a sec, just so I stay under my 20 minutes. Everyone just take a second and solve for y first. All right, so here is the final one, and it's going to be a solid line. The thing you needed to take into consideration here is that you have to solve for y. You divide by a negative, so that meant I had to flip that sign. All right, hope this helped with the lines.